Hello, learners. I am Parikshit, and welcome to another very exciting session on Unacademy CAT-alyst. In today's session, we are going to discuss a set of very important and most frequently occurring questions in past year SNAP papers. Remember, with last few days remaining for the SNAP and the SNAP last year cutoff being high, it is essential that this last few hours you practice the most relevant questions. And this is where Unacademy is going to help you. Handpick questions from past year SNAP and mock papers. And these are the type of questions that you've got to practice a few days before your SNAP. Let's get started. Going to be an exciting class, a lot of learning ahead. Let's get started. So this is me, your educator on Unacademy with the highest live class rating. Thanks to my learners. A lot of batches are starting on Unacademy in the next few days. 15th and 18th of December, we have batches starting for CAT and OMAT 2022. If you wish to enroll for any of these batches, remember you got to use the code Parikshit Live, which is there on your screen. If you use the code which is there on your screen, you will get maximum discounts, and B, you'll also get free mentorship from my side. Yeah, you heard it correct. Free mentorship, and that's available only on the code Parikshit Live in addition to the discounts that this code will give you. Let's get started with today's session. Okay, let's pull up the first set of questions on the screen. These are brilliant questions, questions which have appeared in past year papers. Let's look at the first question. Out of all the MBA aspirants interviewed, 50% of those who attended the first interview received the call for the second interview. 90% of the people. So see, in the SNAP, every question, right, ideally should be solved within a minute. So obviously, if there is such a big paragraph with 4-5 lines, you can't expect to read the question and then go back and collect the data. What you need to do simultaneously as you read, collect the data, write it down. Okay. Out of all MBA aspirants, so let's say let total number of MBA aspirants be 100. You know what? 50% of those who attended the first interview received the call for second interview. So how many received call for second interview? Received call for second interview. 50%. So this is 50 out of 100 is 50. How many did not receive? Did not receive call for second interview. Did not receive second interview call. The remaining 50%. The remaining 50%. 90% of the people who got a call for the second interview felt good about their interview, felt good about their first interview. So remember, 90% of the people who got a call. So how many people got a call? 50 people had got a call. So how many felt good about it? 90% of these felt good about it. So 90% of 50 is how much? 90% of 50 is 45. Correct? 80% of people who did not receive a call for the second interview also felt good about their first interview. 80% who did not receive a call. So we are talking about this 50 on the right hand side. 80% of these who did not receive a call also felt good. So 80% of 50 is 40. Correct? If a person felt good after his or her first interview, so how many people felt good after the first interview? How many felt good? You have 45 plus 40. So total people who felt good, total people who felt good is 85. Is 85. What is the probability that she will get a call, receive a call for the second interview? Receive call. So all out of the good people, out of the people who felt good, how many received call? How many received call? Very simple. So total people who felt good is 45 plus 40. Out of these people, how many received call for the second interview? 45. 45. So can I say 45 by 85? 45 by 85. Think about it. You don't have to do the entire calculations. What you know is this is going to be slightly greater than 50%. Why? If the denominator is 85, 50% of the denominator would have been 42.5. Even if you do the calculations, 50% of the denominator is 42.5. But this is slightly greater than 42.5, meaning slightly greater than 50%. So approximately 53% as per the answer options. Approximately 53% as per your answer options. And that's your answer for the first one. Did you get this? A pretty simple one. A pretty simple one. Got it? Fine. Let's look at the second one. Let's look at the second one. Number two. Let's look at number two. 4 blocks of chocolates of weights 6 1 by 8 kg, 10 1 by 2 kg. So let's write down the kgs. How many weights are there? There are 4 weights. 6 1 by 8, then 10 1 by 2, then 8 3 by 4, and then 3 15 by 16. These are the 4 weights, right? Respectively, were bought for a party. So just make it into improper fraction. 49 by 8. Then the next number is 10 into 2, 20, 21 by 2. Next number is 32 plus 3. 32 plus 3 is 35 by 4. And the last number is 48 plus 15. 63 by 16. 63 by 16. Correct? Were bought for a birthday party. The blocks were divided into pieces such that all the pieces are of the same weight. All the pieces are of the same weight. What is the least number of pieces that can be obtained? Now think about it. Number of pieces should be minimum. Number of pieces should be minimum. Think about it. If number of pieces should be minimum, can I say every piece should be as large as possible? Again, if the number of pieces in a cake should be minimum, then I say every piece should be as large as possible. Every piece as large as possible. And you know what? All the pieces are of the same weight. So same weight and as large as possible. This in maths is nothing but highest common factors. Same weight means common weight. And highest means least number of pieces means highest weight. So highest common weight. Highest common weight is nothing but we are looking at the HCF of these numbers. Correct? So what is the HCF of a fraction? What is the HCF of a fraction? HCF of a fraction. It's HCF of numerator divided by LCM of the denominator. HCF of the numerator divided by LCM of the denominator. Correct? What is the HCF of the numerator? 49 and 21. 49, 21, 35 and 63. HCF is 7. HCF is 7. Highest common factor is 7. Correct? What is the LCM of the denominator? 8, 2, 4 and 16. What is the LCM of 8, 2, 4 and 16? 16. This you got as HCF. What is this? Weight of each piece. Maximum weight of each piece. Maximum weight of each piece. Maximum weight of each piece. You follow this? Clear? Question is not about what is the maximum weight of each piece. Question is rather about how many pieces can be obtained. How many pieces? So can I say number of pieces? Number of pieces is nothing but total weight of all total weights of all k pieces. Total weights of all pieces. So total weight, right? Total weight. So let's say one piece, let's say for chocolate, just to make sure that you understand some random numbers. First cake is 10 kg, second cake is 20 kg. The total weight will be 10 plus 20, 30 kg. 30 kg divided by the size of each piece. Correct? So number of pieces is nothing but total weight divided by weight of each piece. Weight of each piece. Will you agree? So what is the total weight that you can distribute? Total weight you can distribute is 49 by 8 plus 21 by 2 plus 35 by 4 plus 63 by 60. 63 by 60. Divided by weight of one piece. 7 by 60. I think you can do the maths. I will leave it for you to do the calculations. So moment you do the calculations, you will get your answer as 60. Moment you do your calculations, you will get your answer as 67. And that's the answer for the second one. And that's the answer for the second one. Are you clear on this? Are you clear on this? Are you clear on this? Yes? Any doubt in this? Any doubt in this that you have and wish to ask? Any doubt in this that you have and wish to ask? Are you clear on this? Yeah? Fine. Let's go to the third one. Let's go to the third one. Let's go to the third one. Okay? Fine. Let's go to the third one. Let's go to the third one. Fine. Okay. Let's look at the third one. So second one, just mark the answers 53% and then you have 67. Fine. Third one. Find the number of 3-digit numbers which are divisible neither by 2 nor by 3. Neither by 2 nor by 3. Okay. First thing. Number of 3-digit numbers. Number of 3-digit numbers. How many 3-digit numbers are there? Number of 3-digit numbers. How many 3-digit numbers are there? Number of 3-digit numbers is nothing but 100 to 999. 100 to 999. 100 to 999. How many 3-digit numbers? 900. Be very careful. Be very careful. It's not 899. Remember, in other words, you can think up till 1,999. How many 3-digit numbers are there? Let's say from 1 to 999, we have got 999 numbers. 999 numbers. Out of these numbers, you got to remove which numbers? You got to remove 1 to 99. 1 to 99 you remove, because from 100 onwards, all are 3-digit numbers. So basically, 99 numbers you remove. So total 3-digit numbers is 900. Is 900. Correct? Okay. Now, out of these, how many are neither divisible by 2 nor by 3? So find the other way around. How many are divisible by 2 and 3? How many are divisible by 2 and 3? So divisible by 2, think about it. How many numbers are divisible by 2? Now, first of all, I think all numbers divisible by 2. Divisible by 2. Okay. 3-digit numbers divisible by 2 is first number is 100, next number is 102, 104, dot. Last number is 998. 998. Now, I think how many such numbers are there? It is very easy to find. It is very easy to find. This is nothing but an arithmetic progression with a common difference of 2. Will you agree? Arithmetic progression with a common difference of 2. How do you find out an arithmetic progression? Nth term. The nth term of an arithmetic progression is given by a plus n minus 1 into d. A plus n minus 1 into d, where a is the first term, n is the number of terms, and d is the common difference. So here you need to find out n, right? You need to find out n. So what is n? N is nothing but, what is n? N is nothing but, you need to find out n, right? Tn minus a divided by d plus 1. Tn minus a divided by d plus 1. Or in other words, I can say Tn is nothing but the last term. Last term. So last term minus the first term divided by common difference plus 1. So if you know this formula, right, you can very easily determine, you know what? The number of terms. The number of terms. Can you apply this formula? Yes. Can you apply this formula? So let's apply the formula. Number of terms. Last term 998 minus the first term 100 divided by the common difference plus 1. So how much is this? 898 by 2 plus 1. So this comes out to be 244s are 88, 44, 49 plus 1. So basically 450. 450. Correct? Next, divisible by 3. Divisible by 3. How many terms are divisible by 3? Same logic. First term is 102. Second term 105. Dot. Last term is 999. Apply the same formula. Number of terms is last term L minus A. Correct? L minus A. A is the first term. Divided by the common difference. In this case, it is 3 plus 1. So can I say this is 897 divided by 3 plus 1 plus 1. This is equal to how much it is? 3 29s are 87, 299 plus 1, 300. 300. Fine. Now remember, there are some terms which are divisible by both 2 and 3. That you got to remove. Why? As an example, 6. 6 is divisible by 2 as well as by 3. So while counting 2, you counted 6. While counting 3, you counted 6. But you got to count only one time. So any term which you are counting twice, got to remove once. Got to remove once. Right? So divisible by 6. How many terms are divisible by 6? Let's write it down. First term will be 102. 102. Next term will be 108. And last term will be 996. 996. Let's apply it again. Let's apply the value again. N is equal to 996 minus 102 divided by 6 plus 1. Plus 1. So how much you getting it? 49894 divided by 6 plus 1. So find it. 6 14s are 84. 54, 149 plus 1. So basically 150 terms. There are 150 terms which are divisible by 6. In other words, 150 terms have been double counted. Double counted. So you just got to make sure that you remove it once. Correct? So basically, how many terms? How many terms can you say are divisible by 2 and 3? Divisible by 2 and 3 is 450 plus 300 minus 150. Minus 150. So basically 600 terms. 600 terms are divisible by 2 and 3. 600 terms are divisible by 2 and 3. Question is asking how many are not divisible? Not divisible. So not divisible is nothing but total terms minus the divisible terms. Total terms minus the divisible terms. So total terms is 900. Total terms is 900 and divisible is 600. So not divisible is 900 minus 600, which is 300, which is 3. Got it? Got it? Any doubt in this? I think it's a beautiful question. Probably might take some time. Okay, probably 2 minutes, but it is worth doing it because you know how to solve it. You know how to solve it. This is an easy one. Easy one. Any doubt in this that you have and wish to ask? Just in case you are not able to visualize, I will help you visualize again. Terms which are divisible by 2, okay, and terms which are divisible by 3. There are some terms which are divisible by both 2 and 3 that you had double counted. Hence, you got to subtract it once. Hence, this is minus 150, which I had done. Fine? Okay. Let's go to the next one. Answer is 300 for the third one. Fine. Let's go to the next one. Let's go to number 4. Let's go to number 4. Okay. Number 4 on your screen. Okay. All the 2-digit natural numbers. Another previous year snap question. Another previous year snap question. All the 2-digit natural numbers that have their unit digit greater than their tens digit are selected. Okay. Let's say you have a 2-digit number AB. You have a 2-digit number AB. Here, what is it? Units digit should be greater than the tens digit. So can I say B should be greater than A? If all these numbers are written one after the other in a series, how many digits are there in the resulting number? So first of all, how many such numbers are there where the ones digit or the units digit is greater than the tens digit? So think about it. First case, if remember both are single digit numbers, A and B have to be both single digits. So if B is 9, if B is 9, what can be A? If B is 9, A can be 1 or A can be 2. Remember, A has to be less than B. So dot dot dot, can I say A can be up till 8? 8. Why? B has to be greater than 8. So if B is 9, A can take any value from 1 to 8. In other words, there are 8 possibilities. 8 possibilities. Correct? Next. If B is 8, if B is 8, you know what about A? A can take any value from 1 to 7. Why? B has to be greater than A. So A cannot be 8. A has to be less than 8. So 1 to 7, 7 possible. Fine? Next. If B is 7, you know what? If B is 7, how much is A? How much is A? In that case, A can take any value from 1 to 6, dot dot dot, right? So this can continue. What will be the last case? The last case is the one. The last case is the one when B is 2. When B is 2. B is 2, A is 1. There is just one possibility. One possibility. Can B be 1? No. If B is 1, A has to be 0. But a 2-digit number cannot start with 0. Cannot start with 0. Hence, B cannot be 1 because in that case, A has to be 0. So, how many possibilities? 8 up till 8. 1 plus 2 plus 3 plus 4. So, you can write, basically this is nothing but you can apply the formula n into n plus 1 by 2, right? N into n plus 1 by 2. 8 into 9 by 2. 8 into 9 by 2 is 36. 8 into 9 by 2 is 36. 36. So what did I get? There are 36 numbers which satisfies the condition B greater than A. In other words, units digit is greater than the tens digit. The question is not about how many numbers are there. Question is, you are writing all these numbers one after the other. So how many digits are there? Remember, you are writing 36 numbers. You are writing 36 numbers and each of these numbers is a 2-digit number. You are writing 36 numbers and each of these numbers is a two-digit number. So can I say if each of these numbers is a two-digit number, then the total digits will be 72 digits. Will you agree on this? Will you agree on this? Do you understand? Do you understand? Follow? So 36 numbers are there, but all of them are two-digit numbers. So one number, two-digit, 36 numbers, 72 digits. Answer is 72. Pretty simple one again, provided you use logic and common sense. These are questions from past year snap papers. Okay. Next, I hope you understand. If you're viewing live, you can ask your queries. Next, number 5. Next, number 5. When you reverse the digits of the number 13, the number increases by 18. How many other two-digit number increase by 18 when their digits are reversed? Okay, two-digit numbers. So let the original two-digit number, be XY. Okay, and the reverse two-digit number, let it be YX. So they are saying if you reverse, the number increases by 18. If you reverse, the number increases by 18. So can you say reverse minus original is equal to 18? Reverse minus original is equal to 18. Correct? So reverse, what is the number? YX. How will you write YX? 10Y plus 6. Right? How do you write the original number XY? 10X plus Y. 10X plus Y. This is equal to 18. So can I say 9y minus x is equal to 18 or y minus x is equal to 2? Y minus x is equal to 2. 9y minus x is 18 or y minus x is equal to 2. Y minus x is equal to 2. Correct? Fine. Any doubt in this? Y minus x is 2. So if y minus x is 2, question is how many possibilities? If y minus x is 2, question is how many possibilities? Y minus x is 2, how many possibilities? So let's start. Remember, they are all single digit numbers. So it can be 9 and then x will be 7, 8, 6, 7, 5, 6, 4, 5, 3, 5 minus 3, 4, 2, 3, 1. 3, 1. That's it. Can it be 2, 0? Can it be 2, 0? No, 2, 0 is not possible because if x is 0, it is not a two-digit number. If x is 0, it is not a two-digit number. Now here also you got to be very careful. Question is asking, when you reverse the digits of the number 13, the number increases by 18. The number increases by 18. How many other two-digit numbers increase by 18 when their digits are reversed? When their digits are reversed. Now, it means the question has already considered this case. It is asking about how many other numbers are there excluding 13. Excluding 13, how many other numbers? So basically, please do not count this case because this is something the question already told you. Question is saying don't count this, but how many other numbers are there? So you count the remaining 1, 2, 3, 4, 5, 6. So you have a chance. You might mark 7. 7 would be wrong. Correct answer is 6. Correct answer is 6. And that's your answer. And that's your answer. Got it? Clear? Be very careful. Otherwise, you spend so much time and you end up marking the wrong answer. Okay. Next. Number 6. Number 6. Two identical trains, A and B, running in opposite direction at same speed, take 2 minutes. Take 2 minutes to cross each other completely. Take 2 minutes to cross each other completely. The number of bogies of A are increased from 12 to 16. How many more time would they now take to cross each other? Okay. Now remember, two identical trains. So let's say before they cross, let's say the scenario was like this. Just imagine trains. I'm not drawing all the engines, but let's just draw three engines. Let's just draw three engines. So before, let's call it train A, and this one is train B. This one is, let's say, train B. So before they cross, remember they are identical. So equal number of bogies. In my diagram, there are only 3, but in the question it is 12. Fine. And let's say this is train B. Before, this is the scenario before they cross. Can I say the scenario after they cross? The scenario after they cross will be like this. B will be out here. B will be out here. Will you agree? The scenario after they cross. B, they will interchange positions. B will come here. Correct? And A will go here. A will go here. A will go here. Correct? So if they completely cross each other, what is the distance that they travel? The two bogies. The length, the total number of bogies in the two trains together. In our example, if the two trains completely cross each other, it means 6 bogies crossed each other. 6. 3 in A, 3 in B had to cross completely, right? From before to the after scenario. 6. In the question, the train has 12 bogies. So originally, can I say 24 bogies cross each other, 24 bogies cross each other in 120 seconds, because the question clearly says they take 2 minutes to cross each other. So 24, 12 in A, 12 in B. Someone might be thinking, how do you know 12 in B? Remember, they are identical trains. So the number of bogies in both the trains have to be equal. So 24 bogies crossed each other in 120 seconds. And now if you increase the bogies from 12 to 16, what would happen? Bogies only in A, you are increasing by 4 bogies. So how much more time would they take? More time. So it means there are extra bogies, 4 extra bogies, not in B, only in A, 4 extra bogies. So 4 extra bogies would take how much time? Very simple, apply unitary method. 120 bogies, 24 bogies, 124 seconds. So 4 bogies will take 1/6 of the time. In other words, 20 seconds extra. 20 seconds extra, and that's clear. Beautiful question in the snap. Pretty easy if you're able to visualize. Initially 24 bogies, 12 in A, 12 in B, cross. Now A is increased by 4 bogies. So 4 extra bogies. How many seconds? Apply the unitary method. Got it? Fine. I hope you got it. Okay, a few quick announcements. First of all, the plus subscription. The prices you see on your screen are for the plus subscriptions. On any of these plans, right? If you need discounts, okay, and if you need free mentorship from my side, so you need discounts as well as mentorship, both, use the code which is there on your screen, Parikshit Live, to enroll on Unacademy Plus. Discounts plus free mentorship from my side. And again, iconic subscription also available for those of you who are interested. And yeah, iconic subscription, lot of benefits. Remember the code, discounts and mentorship, Parikshit Live. Parikshit Live or Parikshit Saikia. Both the codes you can use. And the Z test is also available for free. Do register using my code Parikshit Live. And yeah, the Unacademy Snap Special is there. It's a free exam. Do register. A lot of free goodies to be won and prize money also to be won, right? Free test. If you need to use code, use my code Parikshit Live for discounts and mentorship. And anytime you have doubts, make use of the Ask a Doubt feature on Unacademy. That is it for today. I hope you enjoyed the session, and I'm going to see you in my next session. Till then, goodbye and stay safe. Bye for now.